Hello friends, today we are going to discuss a paper named as Cooperative Provable Data Possession for Integrity Verification in Multi-Cloud Storage. A paper was published in year of 2013 in the area of cloud computing domain. The Provable Data Possession PDP is a technique for ensuring the integrity of data in storage outsourcing. In this paper, we address the construction of an efficient PDP scheme for distributed cloud storage to support the scalability of service and data migration, in which we consider the existence of multiple cloud service providers to cooperatively store and maintain the client's data. In addition, we are articulate performance optimization mechanism for our scheme, and in particular present an efficient method for selecting optimal parameters values to minimize the computation cost of client and storage service providers. So this is the basic introduction about the paper and the cloud service provider. The developed project is can be deployed on the Amazon EC2 instance. The motivation for developing this paper is to provide low cost, scalable, location independent platform for managing clients' data. Current cloud storage system adopts several new distributed file system, for example Apache Hadoop, Google file system, or Amazon S3 file system or cloud store. So this is just paper introduction. Verification framework for multi-cloud. So, what do we mean by multi-cloud? A previous existing system that was developed are uses the only one cloud service provider. Means user data is stored on only one cloud service provider data. So in our case, we are using multiple cloud service providers. So each service provider can have his own space for storing user data. So this is known as multi-cloud storage. It has many advantages. We will discuss that in little bit. Uh, the third party auditor is a third party which we have included in this paper for ensuring the integrity of data without having the knowledge of data, because third party auditor has no access to the data. So his task is to check whether the file has been modified or attacked by any attacker or intruder. So this is the public cloud which contains Amazon, Zoho, Microsoft uh, clouds. So this is the basic architecture about the project, which contains three layers. First one is express layer, service layer, and then storage layer. So we have in express layer there is a CSP, and on service layer there are three cloud service providers, 1, 2, and 3, and each service provider has its own space or storage layer, CSP1, CSP2, CSP3. So express layers offers an abstract representation of the store resources, and service layer offers and manages the cloud storage, and storage layer realizes the data storage on many physical devices. We have implemented completeness property verification. Uh, in this case, public verifiability property which allows anyone, not just client, to challenge the cloud servers for data integrity and data ownership without the need of any secret information. So user can challenge to the CSP for checking the integrity of data. So this construction is directly derived from multi-prover zero knowledge proof system, which satisfy following properties. First is completeness, second is soundness, third one is zero knowledge. So this is the basic architecture about the CPDP, applying CPDP scheme in Hadoop distributed file system. There is one TPA, there is name nodes, and each name node is connected to different data nodes. A data node is where user's data is stored, and client application is communicate with the name nodes. These are the performance graphs. So we will just move to the SRS. Yes. So the main aim of this project is to check the integrity and verification in multi-cloud storage. Uh, then description of project. CPDP is scheme based on homomorphic verifiable response and hash index hierarchy. Here data owner will request the cloud service provider for the space for data storage. As the request come from data owner, will be received by cloud service provider, and then cloud service provider will check the availability of space or data on server, and then store the data on the cloud, but there is no guarantee for security of data stored on service or cloud service provider. So we are including a trusted third party which will check the integrity of data stored on cloud. In existing system, cloud computing scenario, data owner outsource data on cloud, and then cloud service provider store that data on single server. But there are many chances of corruption the data on server, and user can lose his valuable data. And also there are chances that cloud service provider can access the valuable data of data owner and make some changes. So in our proposed system, we will make use of multi-cloud storage to upload data on cloud. So there is, even if one server is gets corrupted, then also we can get the file from cloud, and here we are distributing the file on multi-cloud service providers. So here we are achieving distributed file system, as the data owner cannot fully trust the CSP. So here we will use trusted third party which will guarantee the security or data outsourced to the cloud service provider. And for the contribution work, we will make use of backup servers. So data which will uploaded on cloud service provider also uploaded on backup servers also as well. So there are mainly two algorithms which are implemented in this paper. First one is zero knowledge property of verification, and second one is cooperative PDP. So we will see what are the hardware and software requirements. These are the basic hardware and software requirements. So paper is and system is divided into some modules, in model 1, model 2, model 3 and model 4. We will see the demo of a project. this is the project which we have developed in C# and ASP.NET in the 3.5 .NET framework. As you can see here, there are we have developed web services named as CSP backup, where backup of data is maintained. CSP underscore 1, which is the cloud service provider 1. uh, CSP underscore 3, which is cloud service provider third, and CSP underscore 2, which is the second cloud service provider. And there is another web service we have developed, which is trusted third party. So when user uploaded the data, it is uh, the divided into three parts, and each part, first part is uploaded on CSP1, second part is uploaded on CSP2, and third part is uploaded on CSP3. And also the three parts or whole file is uploaded on CSP backup databases. And third party has no access to the data, it has only access to check the integrity of file. So we will just see the demo of our project. So this is the main page of project, where user can log in with the system. There are basically three entities in our project. First one is user, second one is CSP, and third one is TTP, which is a trusted third party. So before user has to log in, he has to register with the system first. So we will just register one user. There is same login or registration for CSP and TTP. So we will just register one user. Contact number, then email address, then username. After filling user information, user can click on submit. When user data is submitted on CSP side, once data is submitted, here it is, he will get a message, account has created successfully. So when I trying to log in with the username and password, when user is registered with the system, he gets his password from the mail. Hi Prakash 123, your password is this. Before that, we have also logged into the CSP as well. So I have created one CSP account. So I will log in with the CSP account. Here I can see the home page for CSP. he can approve the user request. User approved successfully. So now can user log in with the system. When user log in with the system, home page is displayed to the user. In home page there are options like upload, download, alert and graphs. So user can upload the files from here. So we'll just check while uploading one file. Suppose I have selected one tulips.jpg. When I click on submit button, uh, in the background the file is divided into three parts, and each part is uploaded on three respective servers. So we have three databases for each CSP, like cloud service provider 2. When I select data from that, I can see one entry here. A file has been uploaded by Prakash 123, block number 2, and digest. What is digest? We will discuss a little bit. Uh, when user file is divided into three parts, uh, hash value is calculated for each file, means for part 1, part 2 and part 3. And when we upload the data, we'll also upload the hash for that data part, means each server can have data as well as the digest or hash value calculated for the data part. Also we have same structure for the server 1 and server 2. So here I can see the list of downloadable files. So user can download the files which he has uploaded or save them into local server. So we will discuss the integrative model which is described in the paper. So for integrity, there is third party auditor is involved. Currently I have one file which is uh, not modified, so I will just modify one data part 1 from cloud service provider 1, and we will check what will happen. For the simulation purpose, we will modify the this uh, part. We will modify the second part of file prakash tulips.jpg. We will modify block 2 equal to where id is equal to 19. We will just modify the block 2 of prakash. So I can see changes in here. The data is modified by the hacker or intruder. So when I log out and then log in again, I see one notification in alert info. When I click on alert info, here I can see the username is Prakash123, file name is tulips.jpg, and what is the notification? Your file has been modified, or your second block of file tulip.jpg is modified. So I can view the alert. A detail is displayed on in here, where the username is Prakash123, file name is tulips.jpg, and notification. So I can recover, a user can recover the modified block from the backup server, as we have stored on backup server. So when I click on use recover button, the data from the third server, that is backup server, has been retrieved and it is copied to the block 2. Yeah, the alert is gone. When I click on download button and select download, the file is downloadable. So when I go to the database back again and select the data, I can see my data is back. So we have when we'll summarize the process involved in this paper. When user click on browse button and selects the file and click on submit button, the data is divided into 3 parts, and for 3 parts we have calculated one hash value, and that hash value is uploaded onto the server with the data. And when and on the regular purpose, we have CSP has provided one service to check the integrity of service. When user logins or log out, that service is called, and what does that service does is to check the each file of that user. Not only the file, it checks the hash value of that file. Means for each block, TPA calculates the hash again and match that hash with the previous uploaded values. If the hash is match, means the data is correct, and if hash is not match, then data is maybe modified by external hacker or attacker. So if data is not match, so then we have displayed an error in alert info module. So after getting an alert, user can retrieve or backup his data from backup server. So we can see the structure of backup server as well. So we have one database name is CPDB backup, where it contains all the data of users of block 1, block 2, block 3. When block 1 is corrupted, the block 1 data is copied from here. If block 2 is corrupted, block 2 data is retrieved from here and copied on second server. If block 3 is corrupted, the block 3 is copied from backup server and it is replaced on third cloud service provider. So this is the basic about the cloud CPDP. So we have plotted graphs which will describe the performance. We have plotted graphs against various parameters while uploading and downloading by user wise. We have uploaded one file, so you will notice one dot here, and we have downloaded that file 2 times, so we can see the two readings in here, and the signature generation time, which is time required to generate the hash values or data digest values for that particular file, which is maintained across file size and signature time. You will see the coding part now. So main thing is we have checked, we have called a TTP service, which is when user log into the system, a TTP home page. So when user login with the login page, it is redirected to the user home page when the username and password is correct. So at the user home page, we have called one TTP service, which this service is declared in the TTP service, and we have called that service to generate alert, and we have passed username for that. So for that particular user, TTP will generate an alert and check the file content or file data or file hash, and recalculating hash is matched with uploaded hash. So from here TTP service is called and username is passed. So TTP will check all files from the user and check the hash values and generation alert. And alert is written in the form of dataset and is written into the dataset and displayed it to the user. So on the each page load, we check we call the TTP service and pass the current username, which is login. So this is the main task of TTP, to check the integrity of data uploaded by the user. So we can move to the conclusion part of the paper, that we have studied and implemented cooperative provable data position for the integrity verification of data in the multi-cloud storage by using PDP scheme. That's all. Thank you.